Hello. In this video, I'm going to introduce the most important of the integration techniques, which is in fact integration by substitution. Integration by substitution is really just learning how to change the variable in an integral. And we know from our work in differential calculus that changing the variable is actually another way of describing the chain rule of differentiation. So you will see the chain rule being run backwards as we do the integration by substitution. Let's start with a simple example. Suppose we want the integral of e to the mx dx. What we could do is change the variable to a new variable u, where we set u equal to mx. So this means that we're taking a new scale, and the way that the new variable changes with respect to the old one is given by the derivative du dx, which is simply the constant m. So we can write this out as du, the way that the u changes, is m times the way that x changes. And that we can rewrite that as dx changes as 1 over m times the way u changes. So this is the way we change the scales that we're using for measurement. And now what do we do with the integral? Well, we simply make the substitution. Mx is u, so e to the mx becomes u. Dx is 1 over m du, because we're changing the scale of measurement. And the 1 over m is a constant, so we can factor that out of the integral. And then the integral of e to the u du is simply e to the u plus a constant. Here what we've done is to simplify to an integral that we recognize, and we know that the derivative of e to the u with respect to u is e to the u, so that's what lets us write down this integral. And then finally we back substitute, we replace u with mx, and we get our function in terms of our original variable. So this is a simple example of a substitution to evaluate an indefinite integral, and we get this as the antiderivative. Let's do a second example. Suppose we want the integral of 2x cosine of x squared. So it's the cosine of the function x squared. We've substituted x squared into cosine. And what we do is we let u equal x squared, so that now du is 2x dx. Why did I pick x squared? Why didn't I say my u was 2x? Well, what I want is to simplify this integrand to make it look like something that I do know how to integrate. I also want to pick u equal to a function, a part of this integrand, where the derivative of u is actually sitting there too. And in this case, the derivative of x squared is 2x, so I have the derivative sitting there. And so this allows me to do my chain rule backwards. It allows me to make the substitution that du is 2x dx, and that will further simplify the integrand. So let's make the substitution. The integral of 2x cosine of x squared dx through the substitution becomes the integral of cosine of u du. So replacing the x squared with u, and the 2x dx becomes du. Well, the integral of cosine of u du is sine u plus a constant. And if we now substitute back what u was, we get sine of x squared plus a constant is the antiderivative. This is another example of a substitution that allows us to simplify. Now at the end, what we can do is check our answer by taking the derivative of sine of x squared plus a constant. And what we get is cosine of x squared times 2x. And to get that, we've used the chain rule because we've substituted x squared into sine x. Whenever you find an antiderivative, you can always check your answer by taking the derivative. So if you are confident about taking derivatives, you should never be submitting an incorrect antiderivative, because you could always have checked it to make sure that you really did find an antiderivative. Let's summarize. Integration by substitution is a change of variable technique. That's really all it is. The goal is to make the integral simpler after the substitution. And when we look for a part of the integrand, the function that we're integrating, that also has its derivative in the integrand. So our example was that we looked for the x squared because it had a 2x sitting in the integrand as well. And finally, you can always check an integral by differentiation.